All right, let's just jump right in. We're going to tackle one of the biggest, most mind-bending questions humanity has ever asked. You know, the kind of question that sits right on that razor's edge between physics and pure philosophy. What was actually there before the beginning of, well, everything? I mean, it's a question that feels so simple, right? It's almost childlike. What was there before the beginning? But as you're about to see, the answer, well, the search for an answer, it forces us to question everything we think we know about reality itself. This is the ultimate cosmic whodunit. You see, the Big Bang Theory, it's an incredible achievement for science. It's our origin story. But it also leaves us staring at this giant, frustrating puzzle right on page 1. So, the story as we know it begins here, about 13.8 billion years ago. Everything we can see, every star, every galaxy, you, me, all of it burst forth from this single point of unimaginable heat and density. That's our starting line. Okay, now this is super important to get straight in our heads. We all have this mental image of the Big Bang, right? Like a giant firework going off in some dark, empty void. But that's completely wrong. There was no empty room. There was no space for it to explode in. The Big Bang was the beginning of space itself. And, even crazier, the beginning of time. And yeah, that's where things get really, really weird. Because to even try to answer what came before, we first have to tear down our whole idea of what the word before even means. You have to thank Einstein for this one. He showed us that time isn't just this universal, constant clock ticking away in the background. No. It's a physical thing. It's literally woven together with the 3 dimensions of space to create the very fabric of our reality, something we call space-time. So time isn't just a ruler to measure the universe, it's part of the universe. But how is that even possible? How can time itself have a beginning? It just feels wrong, doesn't it? Our entire experience is based on this endless chain of cause and effect. One thing happens, which leads to the next thing, and so on. The idea that the chain itself just starts is almost impossible for our brains to wrap around. And this is where this fantastic analogy comes in. Asking what came before the Big Bang is like asking what's north of the North Pole. Think about it. Once you're standing right on the North Pole, any direction you walk is south. The very concept of north just stops making sense. And in the same way, if time itself began with the Big Bang, then the word before might be a logical glitch. Maybe the question itself is the problem, not the answer. But, physics isn't a fan of just stopping at a dead end, especially when that dead end is called a singularity, a point where all our known laws just break down completely. So scientists have come up with some truly wild, mind-bending theories to try and peek behind that curtain, to imagine a kind of cosmic prequel. Let's get into 3 of the biggest ones. First up, we've got a theory called eternal inflation, and the core idea here is that our Big Bang wasn't the beginning, it was just a beginning, just a single local event in a much, much bigger cosmic show. So the theory goes something like this. Way back in the first tiniest fraction of a second, our universe went through this insane exponential growth spurt called inflation. Well, some models suggest that this process of inflation never really stopped. It's eternal. It's constantly creating new universes, like bubbles popping up in a boiling pot of water. Our entire observable universe, we're just living inside one of those bubbles. So yeah, our bubble had a beginning, but the vast multiverse it's floating in, that could have been inflating forever. Okay, but what if the answer isn't out there in a sea of other universes? What if it's right here, in our own past? What if our universe is just caught in an endless cycle of birth, death, and rebirth? This is the big bounce theory. And what it does is it gets rid of that pesky singularity, that point of infinite density where all our math just falls apart. Instead, it suggests that there was a whole other universe before ours that was collapsing in on itself. It crunched down to an incredibly dense state, but instead of vanishing, it bounced. It rebounded back out. And that rebound is our Big Bang. It's this cosmic reset button. And it could have been happening over and over and over again for eternity. All right, theory number 3. If you thought the others were strange, buckle up. We're now diving into the exotic world of string theory. So try to picture this. In this model, our whole 3-dimensional universe is like a giant sheet, or a brain, short for membrane, that's just floating around in a higher dimensional space. And the event we call the Big Bang, it was actually the cataclysmic collision between our brain and another parallel one. They smash together, creating a massive burst of energy. Then they pull apart, cool down, expand, and eventually they're drawn back together to collide all over again, sparking a new Big Bang in a never-ending cycle. So let's just pause and look at this for a second. What's so fascinating is that whether we're talking about an eternally inflating multiverse, a bouncing universe, or colliding brains in a higher dimension, they all have one thing in common. They all replace the idea of a single absolute beginning with a picture of a cosmos that's eternal and always in motion. And it's really important to remember, these aren't just, wild stories scientists are making up. They are all serious attempts to use quantum mechanics to figure out what happens at the absolute extremes of reality, where gravity gets so intense and everything is so small that our standard classical laws of physics just completely break down. And that breakdown point has a name. It's called the Planck time. It is the absolute earliest moment after the Big Bang that our current physics can describe with any confidence. We're talking a decimal point followed by 42 zeros and a 1. Anything before that, and we need a whole new theory, a theory of quantum gravity. And that's exactly what all these ideas, the multiverse, the bounce, the brains, are trying to be. So, where does all this leave us? Well, the search for what came before has turned into something way bigger than we thought. It's not really about finding a simple prequel anymore. It's become about completely rebuilding our most fundamental ideas about reality itself. We're being forced to see that time isn't just some fixed absolute stage that events play out on. It's a dynamic, changing player in the cosmic game. And it means our basic human gut feeling about cause and effect, about a before and an after, it just might not apply when you're talking about the scale of the entire universe. And this quote, I think, just says it all perfectly. The universe is under no obligation to make sense to us. It really drives home the kind of humility we need to have when we're facing a mystery this big. I mean, our brains evolved to survive on the plains of Africa, not to contemplate the birth of space-time. And that leaves us with one last, truly mind-bending thought to chew on. All these theories we talked about, they assume the laws of physics are eternal and unchanging. But what if they aren't? What if the laws of physics themselves were born in the Big Bang along with time and space? Now that opens up a whole different can of worms, doesn't it? And it's the perfect place to leave things for now.